Hi Chemistry, this is Mrs. KJ and I'm going to go over the Unit 5 Chemical Reactions Lab. So in this lab, you will study different kinds of chemical reactions. This laboratory allows you to study various kinds of chemical reactions, including some that result in precipitates. All right, we've seen this word a lot this year in chemistry. Do you remember what it means? So a precipitate is when you start with two liquids. You pour them together and they make a solid. That solid is the actual precipitate. All right, so here's a quick example of what a precipitate is. So we have clear liquid here, and we're adding some more clear liquid. You can see it dropped down and it was clear, and as soon as it hits, we have a precipitate. We have chunky solids. Look at that. So the two clear liquids had a chemical reaction. We know it because there's a permanent color change. So you can see it's clear liquid. And it also has a precipitate, which is the chunky solid that was produced. And in this case, it is lead that gives it that yellow color. All right. So again, just a quick review of what a precipitate was. Okay. So in this lab specifically, we're going to compare and contrast. So compare means how they're the same. Contrast means how things are different. So we're going to look at synthesis reactions, single displacement, and double displacement reactions. We're going to talk about how they're all the same, and then we're going to contrast them and talk about what's different. All right, so here's the picture of that lead that we just saw, that lead iodide. A double displacement reaction is observed as a yellow lead iodide precipitate forms. Knowing the types of reactions help you interpret your observations. When lead nitrate is dropped into potassium iodide, a double displacement reaction can be observed. Okay, so here we have potassium and iodine, so potassium iodide, and there's how many molecules of that? 2, that's why there's a 2 in front, so there's 2 molecules of potassium iodide. And then we're adding lead nitrate. And there's 1 molecule of lead nitrate. And they're going to switch partners. So the K was with the I. Now the K is going to go with the nitrate. And the iodine, the I, and the PB, lead, are going to go together. So we have 2 things switching places, which is why it's a double displacement reaction. And over here, they put that S in parentheses. What do you think that S means? It means that it made a solid. And a lot of times in double displacement reactions, you will see a solid, and then you show that by putting an S in parentheses. Remember that there are different types of chemical reactions. These reactions are as follows. Synthesis. So you have 2 separate things, and they combine to make one thing. Decomposition, decompose. Think about what decomposing means in biology class. Or if you have some old food laying around, it decomposes or breaks down. So in a decomposition reaction, you have one thing and it breaks down into 2 separate things. Combustion. What should you think of when you hear the word combustion? Fire, explosions. And then you have a reactant, which usually has carbon. Usually you have oxygen. And then usually it makes carbon dioxide and water and some energy or heat or light or sound, any of those types of energy. We have single displacement and double displacement. Well, what's the big difference between single and double displacement? Single means 1. So only 1 thing is changing partners. And in the double, 2 things are changing partners. In a synthesis reaction, 2 reactants unite to form a third product. So this is the general form of a synthesis reaction. So any 1 element or compound plus any other 1 element or compound yields 1 compound. So A and B, they're just using as variables to say this could be gold, it could be silver, it could be oxygen, it could be any element or compound. So they just use it as general examples. So here's a specific example. 2 silvers plus 1 sulfur yields silver sulfide compound. And there's 1 molecule of that. I know there's 1 molecule because right where my cursor is, we could write a 1, but since there isn't anything, we just know it's a 1. This synthesis reaction creates a product called silver sulfide. Silver sulfide is black and is recognized as the tarnish that forms on silver. This chemical reaction is the reason that silver must be polished. So if you read any books in the olden days, people actually had silverware made out of silver, not like today, and they had to polish it. They had to rub off the black tarnish. All right, now let's talk about a single displacement reaction. One ion, or one thing, of a reactant bonds with the second reactant. This is the general formula of a single displacement reaction. So you have a compound and an element, and one element from the compound goes to the other reactant, and it makes that new compound. So here's an example. Silver nitrate, and how many silver nitrate molecules are there? 2, plus copper. How many copper molecules? 1. Yields copper nitrate plus 2 silvers. So now the copper and nitrate are together. Originally the nitrate was with the silver. This single displacement reaction creates a product called copper nitrate. It is referred to as copper 2 nitrate to indicate the ionic state of the copper that binds with the nitrate. In other words, they put a 2 here to show you that the copper in copper nitrate had a +2 charge. So we've talked about before that you can look at the periodic table to find the charge of an element after it becomes an ion, after it gains or loses electrons. Everything in group 1 is going to have what charge? +1, because it lost 1 electron. Group 2, the charge is +2, because it lost 2 electrons. Group 3, charge is +3, because it lost 3 electrons. Group 4 shares. Group 5 has 5 electrons, so it gains 3 more. And since electrons are negative and you gained 3 of them, you are 3 more negative, or you have a -3 charge. Group 6 has 6 valence electrons, so it gains 2 and has a charge of -2. Group 7 has how many valence or outer electrons? 7. So how many is it going to gain for a full outer shell in order to be stable? It's just going to gain that 1, so it has a -1 charge. So it's that whole column. That's pretty easy, but you may remember me saying the messy middle transition metals can have multiple charges. So sometimes copper right here is +1. Sometimes it's +2. Maybe it's +6. Okay, it can change. And so that's why they say specifically in this example, this atom of copper has a +2 charge. All right, so this liquid is not water. It's a clear silver nitrate solution, and it's a piece of copper wire. And then this is before the reaction. So this is what you start with, and it's going to turn into these 2 compounds. And look at this. You can see it yields or makes a blue copper nitrate solution. So that blue, now it's blue instead of clear. And this is silver. Pure silver is sitting there. So there was silver in this clear liquid, and now because of the reaction, it came out and you have a pile of silver over there. That's pretty cool. And now we'll talk about the double displacement reactions. Ions of both reactants change places. So here's the general reaction. Any compound plus any compound, they switch partners and make 2 new compounds. So silver nitrate plus potassium chloride. Now the silver, instead of being with the nitrate, is going to be with who? The chlorine, and make silver chloride. The silver has to go with the chlorine. Has to. Do you remember why? Because we always write the positive one first, and the positive has to go with what? Another positive or a negative? Positive and negative attract, so it's a positive plus a negative. A positive and a negative. So over here, positive, it has to go with the Cl because the Cl is negative. Potassium is positive, so we have to write it first, and it combines with the nitrate to make potassium nitrate. This double displacement reaction creates a product called silver chloride. It is a precipitate, a common result of many double displacement reactions. Many yellow and brown colors of stained glass are the result of the addition of silver chloride to molten glass. So kind of a cool real-life application. Hopefully many of you have seen stained glass windows at some point, and that coloration in the glass comes from the different chemicals they add. In the laboratory manual and the activity, including double displacement reactions, there's a column listed as solids. These have been provided to you with a solution form. Don't worry about that. Okay, sorry. Perform and observe different types of chemical reactions by working in a virtual lab environment. So that's what we're going to do next. And then it says, please watch for solubility rules. We're going to come back to that. So instead, we're going to look at the solubility table. Okay, what does the word soluble mean? If something is soluble, it's going to dissolve. So does sugar dissolve in water? Yes. So is sugar soluble in water? Yes, it means the same thing. Soluble means dissolve. Okay, so what if something is insoluble? What do you think that means? That means it cannot dissolve. So if you put your finger in water, does it dissolve? No, thank goodness. So we would say our finger does not dissolve in water. We would say our finger is insoluble in water. Okay, so you can also have blank on this table, which means it doesn't exist, or SL slightly, or kind of soluble. So a little bit might dissolve, but not very much. What this table shows us is that if I combine F stands for fluorine, if I combine fluorine with ammonia, okay, so if I put them together, are they going to dissolve? It means soluble? Yes. What about fluorine with lithium? Is it going to dissolve? Yes. Will fluorine and sodium dissolve? Yes. What about fluorine and potassium? Will it dissolve? Yes. What about fluorine and magnesium? Will it dissolve? No. That's going to produce a precipitate. Okay, so it's going to produce a chunky solid. So this table tells us we can guess, is it going to make a chunky solid or not? All right. So what about calcium? Calcium and fluorine, is it going to make a precipitate or a chunky solid? Yes. Yes, it will, because it will not dissolve, so you're going to have chunks. So that's how you use this table. Now, the little video, which I'm not going to show, there's some little tricks that you can also know whether or not they dissolve. And so I'm just going to run through this. And they call the solubility trips nag, sag. And they say the way to remember this is if you have saggy pants on, you know, the kind of pants that you see people wear and you can see half their boxer shorts sticking out. Well, if you have sag in your pants, somebody old like me is going to nag you and tell you to pull up your pants. All right, so nag, sag. So it says that these are always soluble. So nitrates are going to dissolve. If you have this compound called acetate, like the acetate that you may use to remove fingernail polish, that dissolves, which makes sense. Yeah, you're dissolving the fingernail polish off your fingernails. And anything in group 1, lithium, sodium, potassium, barium, or sorry, not barium, lithium, potassium, sodium, etc. Sulfates, so if you have SO4, ammonium, or fluorine, chlorine, bromine, etc. But of course, there's some exceptions. So they say this one exception is PMS. So if you put these with P for lead, M for mercury, or S for silver, then you're going to get chunks. If you put either of these, group 17 or sulfates, with them, you're going to get chunks. Or castrobearer. So calcium, strontium, barium. If you put them with sulfates, you're also going to get chunks. So this is one way, if you do a lot of chemistry, it's easier to just know these little tricks. But since we're just starting out, we're going to use this table. So you don't have to memorize these by any means. I just wanted to show them to you. And instead we'll use this. So if I say I put iodine with silver, is it going to make a chunky precipitate? Iodine, I go all the way across to silver. It's insoluble, so I will make chunky precipitates. So that's what we're going to use when we do our lab. All right. Okay, you know what? I think I'm going to stop here because my video is about to run out, and we will continue in part 2 in the next video link.